Yeah, it's my great honor to be here. Sorry, to report recent research about my research group. As you know, water, rock, and organic gas molecules were the only raw materials available on the pre-ordinary Earth. So the first life could be have been fabricated from this primitive resource. And experiments in the laboratory suggested that minerals as basic components in rocks not only provide the chemical elements for the synthesis of biomolecules, but also could serve as shown here, the containers, C4s, templates, catalysts, reactants, even can use served as a protector of organics and early cells from the extreme solar irradiation. In particular, in my research group, we put out that the semiconducting minerals may be take more role in this area. So just in the title called minerals may play a vital role in the origin of life. And abundant research proposed that the hydrothermal environments could support early life according to the evidence of twin microorganisms, proper gradients, and active water water rock interactions. Yeah, in the current submarine hydrothermal vents and terrestrial hot springs. At the submarine hydrothermal vents, as now, hydrogen has been proposed as a driving force for the synthesis of biomolecules. By contrast, it is also well accepted that solar irradiation could be the vital energy for the origin of life and land. However, unlike well documented hydrothermal events, there were few experiments enable simulating those conditions in terrestrial hot springs to see whether it could be proper birthplace for early life. When combining minerals with solar irradiation, it is interesting to find some minerals with semiconducting properties could be candidates to solve this problem, as you show here. Semiconducting minerals could produce photoelectrons and photoholes, like this, at the same time. When the energy of incident light is higher than the band gap between the valence band and the conductive band. Notably, due to the energy absorption from light, photoelectrons generally have higher energy and more negative potential than ordinary valence electrons. Based on this, some sulfide minerals such as albandite and sphalerite, whose conduction band is much more negative than reduction potential of most reactions, especially reduction. So they are favorable in the thermodynamics for the catalyzing prebiotic reactions. For example, the reduction of CO2, carbon dioxide. But which minerals abundant in terrestrial hot spring? The answer cannot be found until we really arrived at active hot spring. Recently, we field work in the Tanchong, as you know, Tanchong geothermal field, located in Yunnan, province, South China. This here is famous for its Cenozoic volcanism and present-day geothermal features. In these active hot springs and pores, massive native sulfur with characteristic of yellow in color was observed to deposit along the margin of the hot pore below the water surface. At some ephemerals without changed water, the small amount of native sulfur with a large crystal was deposited on the surface of pyrosilicious sinter. Solid element sulfur mineral is always abundant in modern terrestrial hydrothermal systems. That is in the famous Yellowstone National Park in America, for example. This kind of mineral is distributed primarily in the shallow faultic zone, especially in the faultic zone of the hot spring, due to its hydrophobicity and low density, like this. If we turn over our eyes to primitive Earth, elemental sulfur could come from concentration of elemental sulfur aerosol, which could have higher concentration than other sulfur-bearing gases at low altitude. Of course, it could be from many ions as they do in present day, since elemental sulfur as dominant minerals in early terrestrial hot springs, so its action with CO2 should be a big question worth investigating. In this work, we firstly studied the optic property of elemental sulfur because actually the elemental sulfur has not been given sufficient attention about this. And then photochemical experiments were conducted and a model was built to see the contribution of elemental sulfur to the organics accumulation. Elemental sulfur was found to produce photoelectrons and UV light. Actually, like this, which is due to its direct electron transition when the incident light wavelength is lower than 200, the 280 nanometer. But and the visible light, and the visible light is inactive. It was inactive. So here is this one is a 10 on and 10 off of the light. The current is quite different. So we further obtained the potential of photoelectrons in conduction band and find that there were extremely reducing and favorable to reduction of the CO2. This is you can see this is a negative potential for this elemental sulfur. So it has more negative potential than and those stronger reducing ability. The negative potential is strong reducing ability than previous no sulfide. The more detail shown here. Intensely the Raman spectra and EPR indicates the ring of elemental sulfur. This is because the nature elemental sulfur consists of 8 sulfur atoms, so it ring structure. This ring of elemental sulfur were opened. Were opened and UV light. You can see Yeah, this is a EPRC singer. And we tend off is the implanted the two shorter lived dangling band will be probably reband, and they tend to be initial states. Yeah, open the turn on the ring opened and turn off the ring is also a return to the initial state. This is an interesting phenomenon. Yeah. But we, as so far, we don't know much about these transitioned polar radicals, petrol radicals. But the certain sense is that this radical with paired electrons will actively invent sulfur somehow. This is the ring of the sulfur is opened under the UV light. In the photochemical experiments, we don't have a look at the detailed result here, but just see the conclusion. The formic acid is formed in this experiment condition, and dominant organic products besides slight acid. The presence of a sulfur and the UV light and was closely related to the light wavelength, intensity, pH, and initial concentration. Some of carbonides, even of course element sulfur. This is a reaction. Further, all the elemental sulfur and the UV light can electric for the electron hole, and then the CO2 and the reduction this forms, and then continue the photoelectron and the hydrogen can produce formic acid like this one. So the yield of formic acid is closely these experiment conditions shown here. We use a infra ATR effect and exam in immediately products and find that absorbed carbonate ions only emergent and UV light. Yeah, like this one. Yeah. And UV light, UV light may be more important factor. We propose when the element sulfur was broken and UV light is polar radicals may absorb those charged carbonate ions. Such absorption and bonding will benefit the transfer of electrons from elemental sulfur to carbon atoms. This is the main processes. Now, like this one. So, sum up the experiments showed above. Dangling bond in broken elemental sulfur may serve as active site, like this here. This is active site to absorb carbonate ions. The main reduction force could be higher, reducing photoelectrons from the conduction band of elemental sulfur. And elemental sulfur itself can be served as electron donor, like this one, like donor to make the electron transfer happen. So this is maybe the more important role is the kind of natural semiconducting minerals, sulfur, and the UV light. You can see this is called a photochemical reaction, maybe. Finally, calculating the yield of formic acid in the proposed model can show here. We can estimate the maximum organic production in the early terrestrial hot spring by elemental sulfur, called the CO2 UV system. This is elemental sulfur, CO2 and the UV. It is maybe in the early of Earth abundant. In this model, the cumulative yield of formic acid is function of three parameters. Three parameters, including the signal photic zones, concentration of elemental sulfur, and the area ratio of primitive terrestrial hot spring and the Earth surface. It may be abundant than present Earth of surface in the early Earth. So, in the maximum amount of organics in our model could be calculated like this in this formula. Assume if the terrestrial hot spring only covered 1% of primary Earth surface, 1%. If the 1%, the sulfur at 10 micron could produce maximum 1 billion kilogram per year. This is within 10 centimeter thick photic zones. Under these conditions, we can get so much organic and molecules, biomolecules, which can be, this amount maybe can reach the level basically equivalent to the yield of traditional organic matter. Lots of theory about this organic molecules in the early Earth. We can get a lot of methods, but this kind of the volume is equal to the traditional. For example, the 19 impact shocks just mentioned before. Compared with the high temperature and high pressure hydrogen reaction dominated by hydrogen in the submarine hot spring. Just mentioned that lots of people talked before. The terrestrial natural sulfur photocatalytic reaction showed here. We researched recently, provides an efficient and mild way for the production of small organic molecules in the hot spring and the arrangement of the surface. So, which maybe reflects the transformation of solar energy, transformation of solar energy to available chemical energy by so far, natural minerals, kind of natural minerals, and is promotion to the origin of life, even the evolution of life. Put out here. So the elemental sulfur is a never semiconducting mineral with photocatalytic property. Very good properties. Maybe could convert CO2 and other oxidation molecules into organics, especially terrestrial hot spring in early Earth with abundant elemental sulfur and the UV light could have a moderate, especially low temperature and low pressure and high efficient way to produce organics for life origin and evolution. The more detail can be see this paper published in Science Advance. Okay, thank you very much.